So what we will do, we have this MOSFET. This is the drain. This is the source. And the gate terminal we will be connecting with the drain. Okay. So this is for N channel MOSFET. Similar you can have for P channel MOSFET. We have connected gate with the drain. This is gate. We have connected gate with the drain. Now because of this MOSFET is going to remain in the saturation. What is the condition of MOSFET will enter in the saturation? If you remember the characteristics. If you remember the characteristics of MOSFET. This is your VDS, this is ID, and the MOSFET current initially start increasing and then it remains constant. Okay, it remains almost constant. And from this point, when ID becomes constant, we call this region as saturation region. And the voltage VDS, at this point we call it as VDS sat, because after this voltage, after this value of VDS, MOSFET is about to enter in the saturation region. So this is called as VDS sat. Okay. So in this case, where is your VDS? Here. VDS. And you have connected this drain terminal to the gate. Okay, means the this is same. The drain is connected to the gate, means this potential at gate and drain, they are same. The potential at the gate is same as potential at the drain, because they are shorted together, they are connected together. Okay. What is the condition of MOSFET to remain in saturation region? What is that condition? Your VDS, this voltage VDS must be greater than or equal to VDS sat. Agreed? When MOSFET will enter into saturation? When the value of VDS is greater than, from this portion to this portion, MOSFET is in the saturation region. This is the saturation region. So in this region, VDS is greater than VDS sat. Agreed? Yes or no? Can you see, when value of VDS exceeds beyond this point, then only MOSFET is present in the saturation region, means VDS must be greater than or equal to VDS sat. Now, what is the value of this VDS sat? It is equal to VGS minus VT. Okay, so I'll write value of VDS sat equal to VGS minus VT. VGS minus VT, threshold voltage. VGS minus VT. So VDS must be greater than VGS minus VT, because I'll write here, VDS sat can be given as this, the value of this can be written as VGS minus Vt. Applied gate to source voltage minus threshold voltage. So this much voltage exists at this point. So what is the condition? VDS shall be greater than equal to VDS sat, where VDS sat is VGS minus VT. So I'll write VDS must be greater than or equal to VGS minus VT. Now what is VGS? What is VGS? VGS is the voltage between gate and source. Okay. So I can write this VGS as gate voltage. Okay. Gate voltage minus source voltage. Sorry. Gate voltage minus source voltage. VG minus VS. VGS is the voltage between these 2 points. This is VGS. And I can write this as gate voltage minus source voltage is the voltage between these 2 points. So VG minus VT. I will complete this equation. Now in this case, when I am connecting gate and drain together, VG equal to VD. As gate is connected to drain, the value of gate voltage VG is equal to value of drain voltage VD. VG is equal to VD. It means I can write I'll write here again VDS must be greater than or equal to VG minus VS minus VT. Because I have connected gate with the drain, I will say VDS shall be greater than equal to. So this instead of this VG, I will write VD. VD minus VS minus VT. Okay. Similarly, this VDS I can write as VDS is the voltage between drain and source. So that is drain voltage minus source voltage. So VDS can be written as VDS is equal to VD minus VS. So therefore I write VDS, VD minus VS must be greater than or equal to VD minus VS minus VT. I will make this, let's keep this value as it is. VDS I'll write as VD minus VS must be greater than or equal to VG minus VS minus VT. VG minus VS minus VT. I'll take this Vg here. Vd minus Vg. I am taking this Vg here, must be greater than or equal to, this will get cancelled, must be greater than or equal to Vt. What is Vd minus Vg? It will be Vdg, drain to get this voltage, must be greater than or equal to, so this is minus sign here, minus Vt. Now this Vt is always greater than 0 for enhancement devices. Okay. What the condition I got? VDG, that is voltage between drain and the gate. This is drain and the gate must be greater than or equal to minus Vt, minus of Vt. Now this Vt is always greater than 0, that is positive value. Vt is always greater than 0 for MOSFET. Okay, this value is will be greater than 0. It means it will be a positive value. It means VDG must be less than minus of this. It means VDG must be 0. This indicate that VDG should be equal to 0. Okay. What we have done, we have first connected gate with the drain. Okay. And for such connection, one can see that if VDG is 0, VDG is 0 means the voltage between gate and drain is 0. And because we have shorted it, VDG is going to remain 0. So with this connection, MOSFET can be kept into saturation region. Okay, we have seen if MOSFET, when MOSFET can be present in saturation region when VDS is greater than 0. Now why we are doing this? Because we want to use MOSFET as a diode, and you know when diode is a forward bias, it is conducting, it is allowing the current to flow. So through this current, through this diode, the current is flowing. It means if I am able to operate MOSFET in the saturation region when the constant current is flowing, I can use it as MOSFET. Okay. In the saturation region, you know, there is a constant current flowing through the MOSFET. So if I want to make MOSFET as a diode, what I will do, I will connect the gate terminal with the drain. Why I am doing this? Because you know, to keep MOSFET in the saturation, VDS must be greater than VDS sat. Okay. This VDS is nothing but VD minus VS. That must be greater than VGS minus VT, and this VGS can be written as VG minus VS. So ultimately we say VD minus VS must be greater than VG minus VG minus VS minus VT. Okay. So this will cancel each other. If you take VD and if you take this term here, it will become VD minus VG must be greater than minus VT. And the value of VT is always positive for N-channel MOSFET, which indicate that to keep MOSFET in the saturation region, VDG must be 0. And we can get VDG 0 by connecting, by shorting the gate with the drain. So if I short gate with the drain, we can use MOSFET as a diode. So what you are supposed to do when the question will come as MOSFET as a diode, so you draw this circuit and explain that to keep MOSFET, if we are able to keep MOSFET in the saturation region, it can be used as a diode. And to prove this, you derive this equation and prove that it requires Vd is equal to 0. Therefore, by shorting gate terminal with the drain, one can use MOSFET. Um, one can use MOSFET as a diode. Okay, so you please go through this.